Okay, so now in this example, I'm going to read the application problem to you and show you how to solve this. Okay, so what does it say? It says, for a certain fire hose, the pressure P, the pressure loss P in pounds per square inch per 100 feet of hose. So basically, this is pressure loss depending on the length of the hose. And for every 100 feet of hose, it's represented, the pressure loss is represented by this equation that I have written on the board, where Q is the flow rate in 100 gallons per minute. Find Q for P equal to 15 pounds per square inch per 100 feet. Okay, so, excuse me, P is equal to 15 pounds per square inch per 100 feet of hose. Okay? So we're going to plug in 15, right? So this gives us 15 equals 2 Q squared plus Q. So now what we're going to do is, well, we need to put this on the right. We need to make this equal to 0. So we get 2Q squared plus Q minus 15. We're going to subtract 15 from both sides, and we get this. Okay? Now we're going to see if we can factor this thing. We can't take out any common denominator, so now we're left with factoring. So if we use the AC method and multiply 2 by negative 15, we get negative 30. And so we need two factors of negative 30 that add up to 1. Well, what are two factors of negative 30 that will give us a positive 1? Well, first of all, since this is negative and this is positive, well, since this is negative, they both have the opposite signs, and since the middle coefficient is positive, the larger factor has to be positive. So, two factors of 15, that's going to give me positive 1. Or excuse me, negative 30. Okay? So the two factors have to be close to each other. Well, the answer is going to be 5 and 6, right? So negative 5 and 6. So now we're going to decompose the middle term. And now we're going to factor by grouping. So this is plus negative, so I'm going to do that. And now, what do we get? We're going to factor out this, which is going to give us a 2Q times Q plus 3 plus, and then we're going to factor out a negative 5, which gives us a Q plus 3 here. And now we're going to factor out the common factor of Q plus 3. So we're going to factor out Q plus 3, and that leaves behind 2Q minus 5 equal to 0. And now, by the zero product principle, we know that either Q plus 3 equals 0 or 2Q minus 5 equals 0. We'll solve this. And so that means Q is equal to negative 3 or Q is equal to 5 halves. And we're done. And then of course now here's the thing. We have to check to make sure this makes sense. Now Q, remember what Q represents, okay? So Q represents flow rate, right? It's the flow rate of the water going through the hose. Okay, so now we have to ask ourselves, especially with an application type problem, do the answers make sense? And I would argue that no. No, the answers do not make sense. One of the answers is not possible. Okay? And it's going to be this one. Because it's negative. Can't have a negative flow rate. So this is going to be the correct one, 2.5. So this will be 2.5. So the flow rate is going to be 2.5 2.5 times 100 gallons per minute. Okay, which is 250 gallons per minute. Because remember, this is 100 gallons per minute. Okay? And that's it. So it's essential. So the thing is, I'm going to leave you with this, is essential to always make this equal to 0 to solve these. Okay? Because if you don't make it equal to 0, it's possible to come up with answers that are not going to be the roots of the equation. That's what we're looking for. So we always set it equal to 0 because we're looking for the roots. Okay? And that's it. Have a great day.